Good afternoon. Today we're going to see about the concepts of dynamics of particle. So far, we have seen about an object at rest, that is in static condition. The second part of the engineering mechanics deals with dynamics. Dynamics is classified into kinetics and kinematics. In dynamics, we'll study about the concepts of moving object. If we are considering the force which causes the motion, that is deals with the kinetics. If we studying only the position, velocity, acceleration, and time, which is without considering which causes the object to move, that is without considering the force, is known as the kinematics. While before going into this topic, we must have a clear idea about the distance and displacement. Distance is nothing but a scalar quantity. We'll give the distance in the unit of the distance either in meter or a centimeter or millimeter. It is nothing but the distance covered by an object during its time of motion. Whereas displacement is a vector quantity, it refers how far, that is change in position of the object, how far the object was moved, and what is the final position from its initial position. The change in position is known as the displacement. To know clearly about the difference between distance and displacement, just look at the image. A person walks 4 meters east and then 2 meters south. Here it is the starting position. Then 2 meters south and 4 meters west, and then once again 2 meters to the north. So the total distance traveled by this person, if we ask for the total distance traveled by this particular person, we'll give the answer as 4 plus 2 plus 4 plus 2, that is 12 meters. If we ask for the displacement, the initial position and the final positions are same. So the displacement is 0. This is how we have to differentiate between the displacement and distance. Let's get into another example. Here, the skier is traveling from the position A, then to the position B, then he travels to the position C, and then travels to the final position D. I want to calculate the displacement and distance traveled by the skier during 3 minutes. In the first minute, that is 0 to 1 minute, he travels a distance of 40 plus 100 plus 40, that is 180 meters. Then from B to C, that is on the second minute, he travels another 100 plus 40, that is 140 meter plus 180 meter. Then from C to D, he travels another 100 meter. The total distance traveled by this skier is 420 meter. Whereas the displacement, when we go for the displacement, the initial position here is 0. The final position here is 140 meter from the initial position. So the displacement is 140 meter. Let's check whether our answer is right or wrong. Yeah. So the skier covers a distance of 180 plus 140 plus 100 meter, that is 420 meter. When the displacement is 140 meter, that is on the right side directions. So understand the motion of acceleration, we have to consider an object. First, we have to solve the problems in rectilinear motion. In the rectilinear motions, the object might move in the horizontal direction or vertical directions. We have to arrive standard formulas. Let's imagine if an object starts from rest. So that in all the cases, when the object starts from rest, then the initial velocity will be 0. We have to take the initial velocity as u. Then the object starts from rest and it reaches the maximum speed and travels in the same velocity. So when it reaches the maximum speed, the velocity will be v. That is the final velocity. So sometimes we ask a question like this: what is the time taken to reach the maximum speed? Then we denote the time with the notation of t. A, acceleration, we used to notate with A as for the accelerations and S for the distance traveled in particular time. When it is uniform velocity, the total increase in velocity is equal to at. Therefore, v is equal to u plus at. For average velocity, we have to calculate u plus v by 2. The distance traveled by the particle, that is average velocity into time. We'll get the formula as S is equal to ut plus half at square. This is the formula. When we substitute all the values, we'll get the S value as S is equal to ut plus half at square. Then for finding the velocity, we'll get the equation as v is equal to u plus at. Then the v square is equal to u square plus 2s. These are the standard formulas that we have to keep in mind to solve the problems. When it is in the horizontal directions, we can use these formulas. If it is in the vertical direction, then we have to take h is equal to ut plus half gt square, and this g is nothing but gravitational force. As already said that in rectilinear motions, we have to solve the problems in horizontal direction and in vertical directions. In translation motion is classified into rectilinear motion and curvilinear motions. We'll see detail in about the curvilinear motions, how these formulas were arrived in later classes. So these are the steps that to be keep in mind while solving the problem. As already said that when an object starts from rest, then there is no velocity. So the initial velocity u will be considered as 0. If a moving object comes to rest, then the final velocity will be considered as 0. In vertical motion, if an object starts and moves to reach the highest point, then after reaching the highest point, once again falls downwards. So at the highest point, the velocity will be 0. That v is 0. The final velocity v is 0. Then we assume for the second case, if the object falls from the highest point to the downward, then this v is assumed as u. So we have to take the u as 0 for the vertically moving downwards. That is what's given here. So by using these all standard formulas, we can solve the problem. Now we'll get into the problem in the next class. Thank you.